Aloha, Richard Halverson here. This is ITS128, and today is February 11th. And we are in our 5th week. Let me share my screen. So this is the syllabus, and we are in this period here, and we're doing branching. So this is the first sort of logic that we can add, that we can have the first logic type statement that we're learning in Python, and branching. And there's branching statements in every language. In fact, I think that was one of the first things that they proved back in the 50s and 40s when they were studying computing machines, that if you had a branch, if you were able to test if something is negative, and you could branch on that, and then you had the add, subtract, and you had add and subtract functions, then that's all you needed to build a computer. You could build everything on that. So branching is very important. So let's get started. The textbook here, it's chapter 4, and we have already covered up to Boolean operators. If you look at the last video, oh, by the way, I should, just to remind you, there's this playlist thing now. And so instead of, I think you can subscribe to this playlist. And then I add the new video to the playlist automatically after I upload the video, so it'll show up here. In this class, I happen to be pretty good at posting them down here, posting the videos down here. This is good, you can see where we're at, and posting the videos over in resources. These are the places where the videos are. Now, one thing about coming over here, we've done sections 4.1 to 4.5 is what we've covered already. In resources, you find our fall 2020 videos. And the fall 2020 videos, I helped you out a lot more with the stuff that you have to hand in. Okay, so if you're having trouble, like I'm not going to spend a lot of time this semester in these videos showing you exactly how to do these labs, okay? Because I'm going to tell you enough to get you started, but if you really are stuck, then you should venture back into these videos, and back here I'm a lot more clear on what I'm looking for. All right, so so Boolean operators we covered last week. So next is membership and identity operators. Okay, so a common task involves determining whether a specific value can be found in a list or a container or a dictionary. So there are these operators in and not in, which are the result of evaluating them is going to be true or false. So either something is in a list or something is not in a list. And so, you know, it's kind of pretty, it's kind of obvious. So let's say we define a list called prices, and it's got these 3 things in them. And this expression here, 15 in prices, that's like a question. Is 15 in prices? Or it's a fact. It's either a fact or it's not a fact. It's true or false. 15, either 15 is in the prices list or it's not. And so of course it's going to be true. Notice here we're distinguishing because this is an actual string. This is a 3-character string, and this is you know, a 2-digit number. This is a 1-digit number. All right, so here you know, here's some examples. And this shows the difference between in and not in. It's pretty obvious. So here, testing if something is in a list, if it's true that it's in the list, then it does this first part. Otherwise, it does this second part. Here, we're doing the not in. So if this is true, then that means it's not in the list. You know. So anyway, it's pretty obvious. Membership operators can be used to check whether a string is a substring. So you can do something like this. Now, this is pretty clever. It's the first time I've seen this in a language. Not surprised. So normally this is a function. It's it's not an infix operator. It's a function that's got two arguments. The first argument is the one that you're looking for, and the second argument is what you're looking in. But in Python, they offer they offer the same functionality as an infix operator, which means it's like a plus or minus or something. So this returns a true or false, depending on whether this is a substring of this. All right, checking for membership in a dictionary is in is looking for the key and not the value. So in this case, this is an example here. This is one dictionary entry or one dictionary item, and this is a second one, and this is a third one, and this is the first one here is the key. Let me make this a little bigger. A is the key, and B, and this is the value, which goes along with that key. This is like a name value pair. There's a name and there's a value, and so this is a dictionary. In the in operator is looking for a key value, not a key, not a value. So this is going to be true because B is in dictionary, but this is going to be false because the only ones that are in here are A, B, and C. And so 3 is not in there. See, so this is going to say 3 not found. Which expression checks whether the list, my list, contains the value 15? Well, it's one of these three. You could guess that one. The value. I think it's none of the above. Anyway, okay, the identity operators is and not is. So this is in and not in, and this is and not is. So it's like equal. Okay, sometimes a programmer wants to determine whether two values are the same object, and so this is the identity operator. So it's not whether it has the same value. It's more than that. It's whether they are actually the same object. So if A is Y, then the ID of X is equal to, I mean, if X is Y, then the ID of X is equal to the ID of Y is also true. So that's the ID of the object. So here this is true. X and Y are bound to the same object because of this. It doesn't, they're also equal, but anyway. So that's is it, it's hard for me to think of examples of where you would use is where you're testing with the same object, but I'm sure there are some. This kind of thing is not in any other language that I'm familiar with. All right, Boolean operators detect specific values. Detect specific values. Write an expression using the membership operators that prints a special number if special num is is stored in that list. Okay, so you read it in and you're supposed to say if special list, if special, if special num, that is this right here, if that is in special list, which is this, gotta put a colon, and this is just a comment, so it's okay that that's there. So let's see, oh, this is a challenge activity, so this is gonna use its own data to test. Oh, maybe it doesn't like this. Oh, it's because there's another colon there. What? Oh, yes, that's right. That would not be. That would. All right. So what is it not letting me do? Oh. Okay, that works. What happens if I do this? I'm going to take this, copy this, and I'm going to put that here. Let's see if this works. I tricked it. All right. Anyway, that's not the right answer. You should be putting this. All right. So order of evaluation. Okay, so these are precedence rules, and you know about precedence rules. Of course, it always does what's inside. It always does what's inside the innermost parentheses first, and then it works its way out. And then when there are no more parentheses, then it starts using operator precedence. And in this case, these three. These three have, at one level, yeah, okay, so this is a weird table. But here, the first it's going to do, it's the relational operators always have a lower precedence than these operators that actually do than the arithmetic operators. So so these have precedence over these, and of course these three have precedence over these two. And there's that also. So it's going to do the multiplication first, then it's going to do the subtraction, and then after it does the subtraction, this will be one number. And so then it compares that one number with this one number, and it's either going to be true or false just because of that. All right, so there's that. Logical not. Okay, so not has got a lower precedence than anything above it, including, wait a second. Yes, right. It's right. So it's got a higher precedence than and, or. So when you see this, this is evaluated first, then we say if it's this or this, and it's going to be true or false. So it's evaluated like this. Logical and is evaluable. Okay, so in this thing here, and this is good to know, you know, Pascal, the language Pascal, did not have this operator precedence where it had where and has precedence over or in the logical operators, and it just really messed up my thinking. And so I'm always nervous about assuming that this precedence, but in Python, this has precedence over this. So first, okay, and of course these equality or these relational operators have precedence over ors and ands and nots, okay, because the relational is up here. This is the highest, and this is the second, third highest, fourth, fifth, and sixth. So so first, we're going to do the equalities and the inequalities. So this is done first. This is done second. This is done third. And then this is done fourth. And then this one here is fifth. So anyway, all right. Applying the precedence rules to an expression can be thought of as a tree. Yes, it can be thought of as a tree. All right, so order of evaluation. Now we kind of went through that. Missing parentheses is a common mistake. Yeah, it's because you get the precedence thing mixed up in your head. So when in doubt, put parentheses. There's nothing wrong with putting parentheses. You can put all the parentheses. In fact, you know, it's kind of good to put parentheses because you know, it helps the reader. Helps you too. Next time you come back to look at your code. All right. Yeah, right. Equality has precedence. This has precedence over not, doesn't it? So this evaluates as that. Okay, so this, yes, this is true. This is true because this is going to have precedence over this. So this evaluates as this evaluated first, and this applies to the whole thing. So that's yes. Hope this is right. All right. Anyway, object or order of evaluation, actual parentheses. Okay, so this is a nice participation activity. You do all these and you get all the participation points. All right, code blocks and indentation. All right, a code block is a series of statements that are grouped together. A code block in Python is defined by its indentation level. The number of blank columns from the left edge, okay? And blanks are different than tabs. Okay, so you gotta, yeah, so, and there's not, usually that's where an integrated development environment helps when you're writing Python, because some text editors, it just depends on how your text editor is set, where a tab will actually insert a tab character, which is one single character, or it'll actually insert a bunch of spaces to tab over a certain number of spaces. And so if you open up a Python program that somebody else wrote on some other you know, editor, there could be a bunch of tabs in there, and then when you start editing it, and you end up inserting spaces, and it looks the same, but the Python interpreter says, well, these indentations don't match. So you have to be careful there. Anyway, and this is the only language you have to be careful with this, okay? No other language uses indentation level as a way to define a block, okay? Every other language use some kind of delimiter, okay, which signifies the beginning of the block and the end of the block. So in all the other languages, we still use indentation to indicate a block, but it's only for our own documentation purposes. It's only because that's how we prefer to read it. It makes sense to us. But it's really the delimiters, and those delimiters can be curly braces, or can be the word begin and the word end. But anyway, but with Python, it's actually the indentation. So they talk about good practice, 4 columns per indentation level. Well, that's all preference, of course. Blocks are indicated by indentation. So indentation, this works. First block has no indentation. Actually, the first block is really like this whole thing, and this is a sub block, and this is another sub block. So you see a program that mixes tabs and space to indent blocks will automatically generate indentation error. Okay, so it appears to me that this is okay, which means that it's just that all of the indentations for a particular block have to be the same. So maybe you can mix tabs where if an entire block uses all tabs and another entire block doesn't use all tabs, that's probably okay. By the way, the comment shouldn't really matter that much. All right, so that's interesting. Does this work? Not sure. So fix the errors in the code below so you can run the program. Okay, what's wrong? It doesn't run now. Oh, I see. This is indentation error. I see. This is all about indentation errors. Radius meters. Okay, so you can't mess around throwing blocks in here and there. In other programming languages, you can. You can like just surround blocks with the delimiter characters, and it's a new block, and you have block, block, block. I think one of the reasons why Python is a good programming language is because it makes these good programming practices part of the syntax of the language. So anyway, so you can fix all these indentation errors, and then this thing will run. The errors, we keep getting failed to compiler errors. The interpreter is not able to finish because it comes across something that didn't make sense. Multiple lines enclosed with parentheses are implicitly joined into a single string. So that's like this. That's nice. Okay, so all extra lines are indented to the same column as the opening quotation. So it's got to be like that. Okay, that's good. Containers and so on, dictionaries can be broken up like this. That's nice. Here, these symbols here are used in other programming languages to delineate a block. But in Python, these symbols are used for dictionaries and for sets. We'll see that later. All right, so this is about indentation. Retype the code below. So we're supposed to fix the indentation here, huh? Retype the code fixed. So you should do this. Copy, paste, and it should, if that, then that, else that, else. So it should be something like that. That's probably pretty close to the truth. So it says the city is melting. Oh, if the input is 105. So if the input is 105, oh, here, does this, oh yeah, okay, when this thing executes, this is going to execute. And so it's going to be waiting for an entry, and this will be the entry. New York is, so if New York in temperature, if New York is in temperatures, it is, because this is temperatures, this is a dictionary, and there it is. And if it is greater than 90, okay, this is how you reference a dictionary item. You reference it by its key, this key value. If that is greater than 90, then it's going to say the city is melting. Otherwise, it's going to say what it is. And if this is not in here, then it's going to say it's not in there because this is false. All right. Anyway, so what's next? Conditional expressions. A conditional expression is well, this is another one of these interesting constructs in Python, which you don't see in other languages. So conditional expression has the following form. And so the whole value of this whole thing is all three operands are expressions. The condition of the middle is evaluated first. And if it evaluates to true, then this is the value of the entire expression. If this value is false, then this is the value of the entire expression. Okay, so the when is referring to this condition. Conditional expression has three operands and is thus sometimes referred to as a ternary operation. Okay, so it's got kind of an operator here and an operator here, in sort of, an infix, inside operator kind of thing. So that's pretty interesting. Excuse me. So in other languages, and I mean, in every other language, and in Python, you can do it this way too. You can just write it this way. But this works too. All right, so this tests that. Convert each if-else statement to a single assignment statement using a conditional expression using parentheses around the condition. All right, so I don't know why we have to use parentheses around the condition. Well, okay. So it would be y. No, I'm sorry. It would be zero. Huh? Really? Y equals 0, if, I got to put a parentheses around this, it says, right? Okay. X is less than 100. Close the parentheses. And then what is the other key word here? Else. Oh, I see. There is a parentheses around the condition. Okay. Else X. Okay, so Y is going to equal 0, or it's going to equal X, depending on which one is executed and which one is executed. Well, the one on the left is executed when this is true, and the one on the right is executed when this is false. So is that the right answer? Yes, very good. All right, so conditional expressions. Enter the output of the code. All right, my number is equal to 10 if, oh, okay, it's another one of these. All right, sure. I don't know why this one is not putting, this one just isn't putting parentheses around the condition. Huh. So if I do this. Yeah, it works. All right. So start. My number is 1. If my number is greater than 5, so this is false because my number is equal to 1. So 9 is what's going to be printed. 9. Enter. Okay. This one is going to be 7 because this is true. See, my number is 7, so that's true. So it's going to be this value. So the answer, which is this. So the answer is 7. All right, what's next? Create a conditional expression that evaluates a string to the string negative if user val is less than 0 and non-negative otherwise. So I'm supposed to put a conditional. All right. So I'm going to say if it's true, it's that we say negative. If user val is less than 0, else non-negative. So this is the test. If this is true, the entire expression evaluates just to this. Now, if this is false, then the entire expression evaluates just to this. That's probably what we want. All right, this is another challenge. Using a conditional expression, write a statement that increments num users if updated direction is 3, otherwise it decrements. If update direction is 3. Okay, so it increments num users. That means it adds 1 to it. Write a statement that increments num users if updated direction equals 3. Otherwise, it decrements num users. So it's either going to increment And I think I would write it like this. I would write it num users plus 1. That's the expression if it's true. If what's true? If update direction is 3, that's the expression. Else, if update direction is not equal to 3, and that's the otherwise case, it decrements num users. So num users is minus 1. So this is the expression that's evaluated. Okay, so you would not put num users. Okay, you would not put that because that's a statement. Okay, we don't put a statement here. We put an expression here, and the expression is we want to take num users and add 1 to it, and whatever that ending value is, that's what we want this whole thing to equal. All right, so I'm pretty sure that's a right answer. All right, what's next? Tweet decoder. Oh, right. Okay, the following is a sample program lab activity. Not all classes using Isaiah books require students to fully complete this activity. No auto checking is performed. Users planning to fully complete this program may consider first developing their code in a separate programming environment. Okay, so you know what they're saying is if you want, you can do it this way. So I've got my Python interpreter here, my version 3.9.0. Let me exit out of here. And I have a let me forget about this. Let me just open up a new one. New, and I want to put this in here. Copy, paste, and I'm going to save as. And I'm going to go to my desktop, and I'm going to create a folder called ITS. Let's see, how do I do this? New ITS128 if I don't have one already. Okay, I don't. It's in here, and I'm going to name this program test.py. Okay, so now I've got a program test.py there. And so I want to go here, I want to go to CD desktop. And then I want to go to CD ITS128, and I go dir, and there is my test.py program. Okay, so I'm in the right place. And so let me run this now just to see what it looks like. I'm going to run it. It's going to be py test.py, and it says enter abbreviation from tweet. Okay, LOL, laughing out loud. All right, okay, now what am I supposed to do? Expand the number of abbreviations that can be decoded. Add support for abbreviations you commonly use, or search the internet for, some. Supposed to add some. Allow user to enter a complete tweet as a single line of text. Search the resulting string for abbreviations that use a list of each abbreviation along with its decoded meaning. All right, now that is an interesting one. So what we'll do is instead of entering in abbreviation from the tweet, we will enter in a tweet. Enter a tweet. Enter a tweet. And I don't need this line, character line feed there. Okay, enter a tweet, and then I'm going to say, let's see, we see now I don't in string. We've learned the in function, so I'm going to say, I'm going to call this tweet in. Okay, tweet in. How's that? That's better because no, I'm going to leave it saying tweet, and I'm going to change this. Too bad I can't. It's not LOL in tweet. Well, I'm just going to have to do it that way. So I'm going to say this. I'm going to say in tweet. That's going to be my thing. And I'm going to change every occurrence. How do I change every occurrence? Edit. Control V. Where's Control V? I mean, Control H. It's not edit. Search. Replace. Control H. Okay, so that's what I wanted to confirm. It's Control H. It's that on every editor. It's not on Microsoft Word. So I'm going to search for the colon, and I'm going to replace it with space in tweet colon. I don't know if this is going to work. Okay. Find the first one, not that one, this one. Replace, replace, replace. Okay. And then I'm going to go search for this. Copy. And I'm going to just search for that, and I'm just going to delete it. Okay, so I'm going to do replace, 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 replace. Okay. And what I want to do is what am I supposed to? They want me to replace the LOL with the print a list of each abbreviation. Oh, I see. It's asking you to do that. All right. Well, I'm going to make mine even fancier. I'm going to do. What time is it? 11:15 now. Let me see. Python. Python. String replace. String replace method. Got it. Replace bananas with apples. Okay. So I'm going to say print what is the syntax of that again? TXTX. Okay. Print tweet dot replace left parentheses LOL comma laughing out loud. All right. All right, I'm gonna see if that, and I'm gonna test this just on LOL. So let's see if this works. Let's run this thing. And it's enter a tweet. Did you see that guy's face? LOL? No. LOL. All right, so what does this do? Did you see that guy's face laughing out loud? That's pretty cool, isn't it? All right, so anyway, so that was an example of an in, and what was the purpose of this in the beginning? Just additional practice of, all right, well, anyway, so you can easily finish this by going copy, paste, 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 and then I need to go copy, paste, 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 and I got to close the parentheses. Okay, so I can go, let me save this. Run it again. Oh my God. IRL. They went FTW. LOL. No. I was LOL. ABFN. Let's see what that does. Oh, it only does one at a time. I want it to do more than one at a time. So let me just do this. Dun, 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 dun. I don't need this. Okay, there we go. Ooh, wait a second. Gotta do one more thing here. I'm gonna take this copy. I'm gonna make it be tweet equals that. That, and then I'm gonna say print tweet. Okay. And I'm gonna copy this so I don't have to type it in again. How do I copy it? Does that work? Copy. Okay. All right, so let's run this again. Did I save this? Yes, I did. Up arrow. Oh yeah, right. Dun, 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 dun. Save it again. Okay, enter a tweet. There's my tweet. My God, in real life, they went for the win. I was laughing out loud. Hey, bye for now. All right, that's pretty cool. So that was pretty fun, wasn't it? Let's see. Let's remove. Okay, here. Okay, now we're into the labs. Okay, it's 11:22. That's good. So let's see. I got some notes here. Let me just get you started on some of these. Oops, I didn't mean you to see that. Actually, you could have snapped that, stop it and snap it and get the result, capture what the first couple are. Okay, so for this one, basically, all we got to do is, okay, what this is, you know, colors are represented using three numbers, and it's the red, how much red is in there, how much green is in there, and how much blue is in there. And so now what this is this is a technique that you use to remove you remove gray. You remove the gray part. You remove the gray part of red, green, and of a color. So so what you do is you find the highest. You find you want to take the same amount out of each number, because that's gray. Gray, for example, is gray is where all three numbers are the same, but in the intensity of grayness is how big the numbers are. Like so if it's got no color, you know, gray with no color and it is black. Gray with where these are maximum, where each one, red, green, and blue, is maximum. Okay, that's white. Okay, so by taking out gray, you find that the biggest you can take out where you can take the same out of all three of them. So if somebody inputs 130, 50, and 130, then you can take out 50. You can take 50 out, 50 out, 50 out, and this goes to 0, and the other two go to whatever 130 minus 50 is, which is 80. So you so that's what you do. You got to figure out what the smallest number is, and then you subtract that number from the other two. You subtract that number from all three of them. So the first thing that we're going to do is you want to you want to read in the amounts. So you can read in red equals, and you got to say it's going to be an integer number, and it's going to be input enter red. And you're in this, you aren't going to actually put strings in the input, in the argument for the input function, because that isn't what it asks for. It only wants this to be the output. But I'm putting this in here to make it work better. In fact, I'm not going to put it here. I'm going to put it here. And I'm going to try to finish this up in 5 minutes, okay? And so I'm going to input the three colors: green, blue, blue, and then I got to find this is green, and this is blue, and I better say green. Okay, now we have to use conditionals to figure out which one is the smallest, which of the red, the green, the blue is smallest. So first of all, let's figure out okay, let's just test all three of them separately. There's lots of ways we can do this, but okay, so I'm going to say smallest equals 0. Let's just start out with smallest equals 0, and I can say no, smallest equals the biggest it can be, 255. Okay, and then I'm going to say if smallest is no, if red, this is how I'm going to do it. Red is less than smallest, then smallest equals red. Okay, and then I'm going to go if green is less than smallest, then I'm just having smallest equals green. Next I'm going to do if blue is less than smallest, then oops, tab, then blue or smallest equals blue. Okay, and okay, now we have the smallest, and we can just say, we can say red minus equals smallest. We can say green minus equals smallest, and we can say blue minus equals smallest. And then we just have to print out red, green, and blue. See that? So for any one of these, it starts out with smallest as the biggest it can be. And so whatever red is, well, you can make it bigger. Okay, that's bigger. And so first of all, for sure, this is going to be true. So then now smallest is equal to whatever this is. And if green is smaller than red, then it's going to end up being that. It might not be, but if blue is, then it will be. And so after it's done with these three if statements, smallest will equal the smallest of all three of those. And then you just subtract that from each of these. Anyway, so if you put something like that in there, it should work. And so this is the same kind of thing. Find the smallest number, same idea. I do that same one. This one is where you do a, you figure out if a number is, you figure out if a highway is even or odd. And you also figure out if it's a two-digit, you also figure out if it's a, a 1 or 2 digit or a 3 digit. If it's a 3 digit, it's a service. It services the primary. It's auxiliary. Okay. So basically you're supposed to, so you figure out how many digits it is. You figure out if it's an even, if it ends in 0 or it ends in 5. And then by 0 or 5, you know if it's going east or west or north and south. That's what that does. It's different in Hawaii. And this is something that tests, you're supposed to say by the date whether it's spring, summer, fall, or winter. And basically, you have, there's the months that are all one thing, like you know, January and February is winter, October and November is autumn, July and August is summer, and spring and April and May is spring. But then for March, you have to test if it's March, if the day is less than 20 or greater than 20. And for June, you got to test if it's less than 20 or greater than 20. To be able to distinguish between, you know, the crossovers. So you end up with a whole bunch of if statements. You should be able to figure that out. And exact change here is just you're dividing. You start and you divide by dollars and then quarters and then dimes and then nickels and then pennies. And each time you take the dividend is going to be the number that you're looking at, and then the remainder is something that you take and you divide by the next smaller one. Again, let me just repeat here. If you go back to the resources folder into fall 2020 videos, you can find these labs 15, 16. You can find them here. Okay, find them all here. All right, so anyway, I hope that helps for chapter 4. And next week, I guess we're going to start. Let's see what the syllabus looks like. So I did finish chapter 4 here. Right, so next week we're going to start loops. All right. Any questions? See you next week. Take care.